This is a mind-blowing statement that you just made, Stefan. I'm literally getting goosebumps. This is a new way. This is kind of like you just gave me a new way of think of the whole technology. Amazing. So today we have an amazing guest. It's the real truth for you guys today. Today we have Professor Stefan Schneider. Stefan, welcome to the Autonomous Vehicle Safety and Security Podcast.
Thank you very much. I'm looking forward now for the discussion.
Now, here are three things you definitely should know about Stefan today. Number one, Stefan is a professor of ADAS, professor of ADAS at Hochschule Kempten. And at the same time, he's a professor at Shibuya University, Shibuya Institute of Technology in Tokyo. So his two offices has the longest distance you can imagine. That's number one. Number two, and I have enormous respect for that, he's a mathematician. So, if I knew before I started studying what computer science really is, I would have studied mathematics. So I have enormous respect for that. That's second. The third thing is, he is a mountaineer. He goes hiking in the mountain, he goes mountaineering, and he goes with a bike.
Yes.
So these are the three things I think you should definitely know about Stefan. So Stefan, with all these things, I mean, being a professor in two universities with, of course, the longest distance, you can imagine being a mathematician and being a biker, mountaineer. How did it all begin? Can you tell me about your story? How did all these things? How did you get inspired to all these things?
So, well, I'm coming from the area of the Allgäu, and this is why my father started to work with Fendt, so agricultural company, and he was working as a engineer at the company Fendt, and my grandfather, he was agriculturing doing so the linearity, agricultural, mechanical stuff. Then it was shouting for mathematics. So my father always said, if you do something, then do mathematics. And this is why I started with mathematics. And I'm really happy to do that. I had minor subject physics. So it opened me the world, so to see. And you see a lot in the world. And besides, I was in the Allgäu, I was always seeing the mountains. So it was a challenge to get there. And when you walk there, you have a good time and to rethink all that you have learned from in the university. So a lot of my friends from university, we were always going out, dropping out of the lectures and then taking the train to the next mountain and being the weekend in the mountains. So this is why I get loved and used to the mountains. Yes.
Fantastic. Now, you're a professor of ADAS. So autonomous vehicle, in my opinion, is one of those technologies that is going to change the way we do everything. In my opinion, right after agricultural revolution, this is going to be the biggest change in the history of mankind. So this is going to change a lot of things. Of course, AI is not only going to shape up, how we commute, but it's also going to shape up many other things. But when it's going to shape up how we commute, it will have an enormous impact in our life. Now, one thing that this audience of this podcast they want to know is about safety and security. And you have worked with safety for a long time. I've been to your several safety talks. So what is the challenge that we're facing today in order to make autonomous vehicles safe?
So I think the technology is available. So since Dickmann started in the 1980s with developing, so the idea is available, technology is available more or less. Of course, there are some corner cases that we have to look at and all are interesting things for engineers. But the major problems from my point of view are at the moment the human-machine interaction. So as you said, KI, artificial intelligence, is a good way or software itself is a good way to transport my idea in my head anywhere else in the world in your head by typical means like here tele invitations and so on. But to real move, you need autonomous systems. So there's planes, there's trains, there is vehicles. And the most challenging is really the vehicle, because this is always I talk to students. If you go in a theater, so and the regisseur of the theater, he has his plot, and then he tells the protagonists, and then the door opens, you come in, then you take the gun and shoot the other one down, and he has to fall down realistic. So this takes weeks to implement this plot into the head of the people. But these autonomous systems, and especially the cars, they have the problem, the inverse problem. I call it always the inverse theater problem. They have to deduce the plot of the scene from just seeing moving the participants in the traffic, what they are doing, at least for the next 10 seconds. And this is enormous hard to resolve, so and to understand. And this is one basic problem. And then we have to so the next challenge is, how can we talk with our car? How can we talk with our environment? So the human-machine interaction and the user experience is important. And finally, the social acceptance and here the homologation are big topics. And as you know, in Europe, we are following the Vienna Convention. So we have big problems for the homologation. And the United States, for example, they did not follow the Vienna Convention about traffic. So they are much ahead, and so it's really interesting to follow these topics.
Yeah. So you mentioned three very stimulating points. First is the perception is the challenge. So you will have to the perception that the autonomous system will have to perceive the situation, and as we know, there is no limit of situations, and there are extreme corner cases. Second is you talked about human acceptance by society. I think the second one was homologation, and the third one was acceptance by the society. So let's talk about each of these.
Yes.
Before our talk, you also talked about digital twin and the topic of perception. And if it is safe enough, I mean, there is always a question, how safe is safe enough? So we need to have enormous amount of test data, right? So tell me first, for our audience, in a very, very, accessible way, what is a digital twin of a vehicle?
So digital twin of a vehicle is a representation in software about all the states of the vehicle. So I need to know how many wheels there are. I need to know the state of the wheels. I need to know where I'm driving, which velocity, and so on. This is so I need all.
Is it the simulation?
It's a kind of simulation. It's a basis, a model. In fact, it's like a model. So I have a virtual representation in the computer of the vehicle, of the important parts of the vehicle that I need for my specific task. If I have to tune a motor, an engine system, I need to know how many valves there are, and need to know when they have to fire, and all this stuff. And this is the same with the driver assistance systems. I need to know how do I perceive, what is my own velocity, which direction I'm heading, and so on. So I need the model, or the representation, or virtual or digital representation of the vehicle. So this is what we can call a digital twin. So it's just a model.
All right. So if we have a digital twin or a model, you can test a lot of corner cases, I assume. So now, we have seen this kind of simulators in the past in automotive industries. They typically use game engines.
Yes.
Now, the problem with the game engines, those who played Counter-Strike know that sometimes you see that you're walking inside a wall. So you don't really quite accurately simulate the physics. So what is the difference between what you're doing at your university, your research group with the digital twin, and the traditional game engine way of developing a digital twin?
So actually, the George Box said all models are basically wrong, but some are useful. And the designer of a model or digital representation or digital twin has to understand the use cases and to be there appropriate exactly where it is necessary for the task I'm looking for. So for example, even for different ADAS functions, I need to be very specific. I need the different balanced models. If you compare a traffic sign detection with an autonomous braking system, so the autonomous braking system does not need to know about the traffic signs at all. So it needs no representation of the traffic signs, but it needs a representation of the streets, of the curbstones, and so on. And the other way around, if you detect the traffic signs, you don't need to know about anything about the road. So it's just interesting. Okay, from here now I have to. I'm not longer allowed to drive 100, but I can only drive 50 here. So you have to. This is the designer of the model. He has to be very. He needs to understand the use case and then come up with an appropriate representation of the digital twin of the model. And here in the ASAM, there's a big effort in the ASAM group. It's the Open Simulation Interface. And the Open Simulation Interface brings together all the items that are most possibly or most likely that vehicle situation will focus to. I don't know any other activity at the moment that brings in together all the interesting parts that are the protagonists in our vehicle theater. So call it like this. Yeah. So this is so the point that is the difference. For example, to Grand Theft Auto. For the games. But to be fair, these technologies are converging. So autonomous systems, developing autonomous systems, robotics, especially for industries, and also game engines. So the game engines are very good in the immersion of a situation. But the vehicles in the game engine, they behave like just cartons walking around or something like that. The other way around, in the automotive industry, you have good models of tires and so forth. But the simulation is not so, I say, for a human so interesting like the game engines. And,
love that.
And this is now converging and coming together. And
it's converging.
And here we have also some colleagues at the Department of Informatic, Computer Science, and they have experience in game engine. And one of my best students are coming from the game engineering bachelor course because they have good idea how to representate this in a kind of model or digital twin or virtual representation, whatever you call it, and to bring in the assets from the automotive industry, which is not the presentation, but how it functions. So, and this makes actually a lot of fun to bring it together and see what's happening. And so all the automotive industry is always focusing of the digital representation of the ego vehicle of the, but they because they know they cannot make a model out of the reality outside of the environment. No one can.
Love that. You started with a quote.
Yes.
Just from my note, who was that quote from? That every model is wrong. What was that?
Box. This is a quote from George Box. He was
George Box. And a bit about George Box, for those who don't know George Box.
George Box was a famous, or still is, I don't know, a famous mathematician dealing with statistics. And yeah, this is a very famous quote from him. Basically, all models are wrong, but some are useful. And
Some are
actually,
useful. I love that. I
and this
love that. So George
actually,
Box, mathematician, his quote. I agree. You know, you cannot. Maybe you can, but we yet cannot 100% model reality,
yes,
because reality, you know, according to David Hoffman's book,
mhm.
reality is a model. It's a simulation. We live in a simulation, right?
Yeah,
So, you know, how can you simulate the simulated one? So, you know, the question is, like Elon Musk said, are we in the, you know, out of 1 billion, are we in the nth layer of the simulation? We don't know. So, keeping that philosophical topic apart, I love the stuff that you brought up. You brought up Azam Group, like, you know, they're coming up with open simulation is standards, and they're converging. So tell us a little bit about this open simulation. It's the standard, I assume, right?
actually, there was at the Technical University of Munich, the colleague Biebel, and there were some PhD theses. How can we represent the environment, not the model of a car, but the model of the environment of the car? And what are the topics? And if we now start to discuss, you need pedestrians, you need bicycles, you need motorcycles, you need curbstones, you need everything. And there was no standardization for that. And so they started with a couple of PhD theses, and this was called OSI, Open Simulation Interface. And this was then an asset which was in collaboration with BMW. And then there was the big, project Pegasus from my estimated colleague Winner, Hermann Winner from TU Darmstadt. And there the BMW bring in this asset of the open simulation interface, and it was kind of maintained. And in the end of the Pegasus project, there was the question who can maintain the 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 added values on the open simulation interface, and BMW then decided to give it to the ASAM, Association of Standardization and so forth. And here we are working together with these guys for yeah, bring in as much as possible interesting players. Also Google and I think Tesla was seen already in these discussions, and to bring in all the assets, because no one, I'm sure no one can think of all these things what can happen out there, and we need to collect our knowledge and bring it together. And so in the ASAM, it's a JIT, you can access to it and can directly develop. And I think it's a good basis to start with. That on top on that, you can then focus on what you are interested. So one is interested in the vehicle, the other is interested in the environment, the next is in the simulation and so on groups. And so you can benefit from all these different things that need totally different skills to develop. And so it's it's a big
It's a
open.
big thing. It's a big thing. And what you just said is, you know, one thing is to simulate the vehicle, but the environment is much more complex. Like, you gotta model pedestrians, bikers, you know, traffic, weather condition, and whatnot. I mean, this is an amazing topic.
Yes.
So I think that I think this is the perfect segue to go to the second stimulating topic you mentioned when you were actually, you know, in the introduction part,
Yes.
is homologation.
Yes.
So homologation is a challenge right now, in terms of cybersecurity. There are some new laws. You mentioned that United States did not take part in the Vienna Convention, not the Vienna Convention you mentioned.
Mm.
So tell us your point of view. Where are we in terms of homologation? Where are the gaps, and where are we heading?
So if you think from the automotive industry, they are always thinking in the V cycle. So, and one topic is to keep the testing amount as small as possible. But with these other topics, as we have already discussed, there are so many unforeseeable things are happening. So it's not clear how to test all this stuff. And if you now think, if you and even if you have a status that is in a homologation, then still, if you do just a software update, then you have to redo everything. And what we at the moment see is actually that the tier one suppliers, they tell the OEMs how to do, or they want to tell the OEMs how to do the perception layer of the vehicle. So they say, look, if you buy the sensors from us, and you place it actually at that place at the vehicles that we tell you, then you can benefit from our validation and verification efforts. If you don't do buy sensors there and from a second company and do your own fusion, then it's your topic to do the verification. So, and this is now a kind of a game of influence at the moment that we observe, and it's not clear who will win this. There was something in the semiconductor industry 30 years ago. It was called the tin can company effect, so that the OEM still give the outside of the vehicle, but the inside will be provided. The architecture of the vehicle will be provided by the tier one suppliers. And and we observe this now as not only from the OEMs but also from the semiconductor suppliers. So
Is it going are we talking about in the direction software defined vehicle?
yes, that's it. Really.
Okay. All right. So for our audience again, can you tell us like what is software defined vehicle and yeah, how would it work?
So the idea of is that you look at the vehicle not longer from the combustion part. So if you look BMW, Bayerische Motorenwerke, so the engine is in the company. Daimler was starting also with the engine. So this was actually the machine that makes us moving. And now we switch. The engine is no longer so interesting. Of course, it's an important part of a vehicle, and you can't move without an engine. But the added value at the moment comes by other features. So how you perceive outside the vehicle, how you feel inside the vehicle, what is the entertainment, and so forth. And this is all done by software. So from a combustion-driven vehicle, we now come to the software-driven vehicle. So, and these are the big parts. And this is actually where the companies make the money. With the vehicle, because it's not important what kind of motor you only for a small group of users of a brand. It's important that this engine with these features and so forth. But the most people don't look at these points so interesting. But it's interesting to have, for example, new features in the vehicle, like I don't know what as you, for example, gestures in the vehicle that steer the radio. This is a cool feature. If you have that, you can say I'm ahead in technology and so forth. So yeah, so I think the software makes it.
So which company is ahead in the race? Which OEM is ahead in the race in terms of a software-defined vehicle? The reason I'm asking this question because I was a speaker in the autonomous vehicle conference in Los Angeles last week actually.
Yeah.
And when I was in that conference, this gentleman after my talk came to me and started a conversation, and he said that he bought a Rivian, hoping that this would be the last car he will ever buy.
Okay.
And his idea is because with software update, the car feature is going to get updated. So which company is ahead in this software defined vehicle race?
So this is really big question. So you see, on the one hand, we have, I say, the old industry. So all these companies coming from the, I say, engine, yes, from the combustion engine. and they are very good in the production. So they have now the 10th series of vehicles starting every 7 years or something like that. They have knowledge about, they have a world wide web of delivery chain. So everything is working and is highly optimized. On the other hand, we have the new kids on the block, I say. They come like Apple, Google, Tesla, and they have not all this ballast from history. They come on the green and start. What is a car? I take an electrical engine, 4 wheels, and let's go. So, and what can we place on software features inside? So, really interesting questions. I think the old industry takes the lecture. So BMW, for example, the head of BMW just said, we are focusing to a company that is dealing with these new technologies. The other companies like Apple, Google, Tesla, and the Chinese companies, they are coming from the other side, and they are looking more from the human interaction interface to a vehicle. So what can we offer the people? And Apple, of course, you have the one experience. Maybe the car is coming, maybe not. We don't know. But yeah, and they want to take the burden of driving from the drivers and make them to passengers for their services, so that it's a perfectly room that you can make advertisement or sell your products. And I had also talked with guys who make games or even cinemas in vehicles. That's the idea, because it's a perfect situation. You have a clear place. Your eyes, your ears are located clearly at the position, and you can optimize the experience of a movie in a way that is not possible as you can do it in a cinema for all the audience.
I've heard it before. I mean, I've heard it before that mobility as a service, the companies will make more money from this kind of entertainment, infotainment, or social media kind of things. Then they will be actually making money from the mobility itself. So you were very generous calling old companies and new kids in the hood. I call them dinosaur companies or legacy companies at best. And they will have their problem. I mean, the only thing I wish that we don't see the Nokia history repeated again, because the hardware, the engine or the motor, let's say the hardware, this is commoditized. There's not much innovation you can do there. There will still be some innovation, but this will not be an exponential innovation. The exponential innovation will take place in the software. The things that you have mentioned.
For sure, this is all these other things are getting commodity stuff, and you can buy. Of course, if you look in details, you will find interesting things. I don't want to blame the guys that are doing good jobs over the last 100 years, but in terms of making business, so I think the big business you will do in the software edit functions. And for example, like the vehicles are apps on 4 wheels now. So you buy a vehicle with a good sensor setup, and then you can sell updates from time to time. And so, yeah, it's like a app store, or that you get new functions. And actually, this is a revolution in the development of systems. If you think of Ford's introduction of the line production, now we do it in another way, that we produce potent products that we can apply later on apps at the time where the vehicle was already built. These apps were not available, and place them. So this
mind-blowing.
So you head up inverts. and I think this, we all don't know at the moment what this makes open for disruption effects, and this is where the
What you
company.
just said is mind blowing, because the Ford's assembly line, you had the product coming out of the assembly. This is still the case for legacy OEMs or dinosaur OEMs. This is still the case, but what is going to be is what comes out of the assembly line is only the beginning of the application. This is something that I think the audience should take. This is a mind-blowing statement you just made, Stefan. I'm literally getting goosebumps. This is a new way. This is kind of like you just gave me a new way of think of the whole technology. Amazing.
We can be part of that, Hassan.
We can be part of that. We can be part of that. Yeah, we can be part of that. The mission statement for Matrickz is we want to make autonomous vehicles safe and secure. Without safety and security, it's not happening. I know your group is working on that. You're creating cool stuff. So we'll definitely be a part of it, and we'll make it happen. I'm going to go to the last bit of the 3 points that you started with. The last point was social acceptance.
Yes.
Which is a very difficult topic. And you're I think one of the most interesting person to ask this question to, because of your longest work distances between your two offices, to jobs, because you know the European culture, you have seen it in Asia, in Japan, right? The social acceptance. So tell me about it.
So this is a very good question, because in Europe we have like kind of a culture of I am always a victim. If you're riding on the motorway and there's someone ahead of you, and why don't he go right so that I can go ahead? So, or why is there again a construction site? I am the victim. I am the victim. So the Japanese, as I understood, they think in another way. They think, oh, I'm sorry that I'm part of this traffic jam, and that I am the cause or the root, that I make it. All the others delays in their travel. So they are more thinking of that. And you cannot imagine what difference this makes in the developing of machines or vehicles, and even of living together. So sometimes it's also personal good advice to change the role from a victim to someone who is the root cause of a problem. So what can I contribute to solve to that? But this is other talk. Maybe we can do another time.
It's mind blowing again. There was this joke that when you are driving at in a 50 kilometer an hour zone at 80 kilometer an hour, then everybody else is too dumb to drive, too slow.
Yes.
But when you're driving 45 and someone else is driving 80, that's the crazy person. It's from your point of view.
Yes.
Yeah. So this totally reflects, the way our fabric of our societal mindset is. Obviously, in Asia, it's totally a different mindset, which you have more experience with. I've been in Japan once only, so I don't really know as much as you know. So I want to know, because I have heard use cases in Japan, especially.
Mm-hmm.
It's not about social acceptance. They need autonomous vehicle because their population is aging. There are a lot of people who are not able to drive. So tell us about that. What's the difference in terms of acceptance in Europe, North America, and in Asia, especially Japan?
Yes. So if you look at first of the development of the society, so Japan is the very first society that goes in the overaging. And due to their policy, they do not let in people to work for a long time, as we have in Europe or the United States. And therefore, they need machines to support that. So there is a real support, a need of supporting machines. And you see this in the robots they are ahead. And so this is the need. On the other side, they have also the philosophy So, for example, this pencil can, or this book here, this has a soul. So, also a machine can have a soul because of their religion. So they are Buddhist
Wow.
and Shintoists, and they anime. So the nature is animated. So they can. There's not so big problem that also a machine can be accepted,
So,
as a part
so
of the
in
society.
Japan, a car has a soul.
I don't know if they would say like that, but they
Okay.
have not the problem as we, that is a machine, but it can be seen as also more or less a part that can take in the society. So they have all the robots, for example, for the students, they support them, and so forth. And they have the robot hotels and so on. It's not so big problem. In Germany,
Yeah, I have seen that those robot waiters. I've seen my first time I've seen it. Now we're seeing it in Germany, but my first time was in Japan.
yeah,
Those little waiters, smiling face robots coming toward you.
and here in Europe, we have always say, a machine, do I want to have it in my life? No. So it's very, say, carefully about that. Maybe this is because of our religion, because Christianity says you are not allowed to have workers or slaves, and machines are kind of slaves, so it's different and so on. And I don't know about it, but this is just my thoughts about. And I think this makes it so for Japan, they have the need and they have a mean to accept them. So machines are everywhere in their life and robots, and it's not a big problem. So one of in the United States you have Superman. Yeah, so he is the guy who solves all the problems. In Japan you have robots, flying robots. They support you when you need. Gandalf, I think, is one of them, and he is always he's good seen. So I don't think so that. So this is the difference, and this is
That's
why.
like their superheroes are robots. That's an interesting point. That's an
Yeah.
interesting point. So, in terms of acceptance, there's another interesting point is we in Germany, let's say we have 3,500 people fatalities, deaths due to car fatalities every year. Uh, the number changed during COVID, but this is like the average case. Now, if we can reduce this number to half with autonomous driving, logically, it's it should be accepted by the society. But what happens is, this is what I think. In the last 10 years, I could remember one plane accident in Germany, and a couple of hundred people died.
Mhm,
And it was all over TV.
mhm, mhm.
Every year, there are 3,500 people dying. Nobody talks about it. But whenever there is an autonomous car doing something, it's all over the media or around the world. So we are, there's a hype. If autonomous vehicle is doing something wrong, it's a hype. It's over. The focus is too much on that.
Yes.
I think with time, people will need to get uh, need to get less sensitive or more accepting toward autonomous vehicle making accidents, and this is where the acceptance will happen. What do you think?
So this is also a good question because the philosophy has two views on that. The one are the utilitarists. They say we have costs, we have benefits, let's balance it. And if, for example, insurances are working like that, we have costs. When a car has a crash, we have a lot of members and we balance it. And this is the idea of insurances. But there's another point of view from philosophers. It's Kant's positions that every single individual has a valid or value that is not balanced with anything else. So it's every living being is worth for its own. So the Würde, dignity, I think, the dignity of the people. And
fascinating point. Fascinating point.
And I think the media are always going on the dignity point. So
yeah,
but this can't be that a new technology involved comes to death or causes death. And of course, this is clear and it's understandable. But we need a lot of machines and we accept a lot of deaths and injuries in other things and in other industries or developments or medicine or and so forth. And so this is actually a not fair game.
No, what you said, is also a very important point. So from a collective perspective, if we go from 3,500 to, I don't know, 1,500, it's a win. But for the one of those 1,500 victims or the families of the victims, it doesn't matter. Every life, like you said, every life is important. From their perspective, they've lost their family member. So that's an amazing point. With that, Stefan, I want to also touch a little bit about your current master's program.
Yeah, great.
It's an ADAS master's program.
Yes.
And to the best of my knowledge, I'm not actually looking at browsing for master's program, but I'm not aware of that many a master's program in ADAS. Mm-hmm. So some of my audience, they're students, they want to come and study in Germany. So tell us about that.
So yeah, please come to Kempten. So we have the Master of Advanced Driver Assistance Systems, and we deal about all the components, about the vehicle, about the environment, and about the driver, of course, how they play together in the system then, and of course in the interaction chain like sense, plan, act. And we have a lot of modules that you learn about cameras, about radars, about perception, about artificial intelligence algorithm, about fusion, about the vehicle also, the driving dynamics of the vehicle, and a lot of the social aspects of the law problems, about the human-machine interaction. We have all these bring together so that in the 3 semesters you get the degree of a master. And all my 250 students that have passed now the master, they have started with the companies before they were handed out their diploma. So this is absolutely, if you want to see, and more than 10 students were already also in Japan and made a semester in Japan. They did their master thesis, for example, there. So this is a big experience for that. And we have a lot of other interesting things here. Also for the free and spare time. We have the mountains and the lakes around.
It's a beautiful place, beautiful landscape. Kempten is amazing.
Please come and study, and you get a good job all over the world, in any position, in the OEMs, in the tier 1 suppliers, at the TÜV, at companies like yours, Hassan. And we are collaborating with a lot of companies, OEMs, tier 1 suppliers, and so forth. And so I'm.
So Stefan, what is the language of instruction?
At the moment, we are still in German. So, but we think of having also at least some modules in English.
Gotcha. Fascinating. So, Kempten, amazing place, amazing professor. You have already experienced him firsthand. It's an amazing university. I would 100% recommend this program if you want to get into the German or the international automotive engineering market. This is an amazing way to do that. And we have close collaboration. We'll also take, we're also planning to take some master thesis in our company in the area of car hacking, automotive cybersecurity, and so on. So this will be an amazing thing. Please approach Where should they go if they want to join this program? Do you have any link? Should we attach some link in the
Yes,
video?
that would be great.
So what we will do, we will attach a link in the video. So feel free to go and join this program.
Yeah.
So Stefan, my last question to you: is there any topic that I haven't covered but you would like to address today?
So actually, about the hacking, we should discuss, because
Yeah.
really important that we have a secure or an untouched or not listened interaction with the vehicle, because the vehicle no longer is the tin with the four wheels, and there's a surface around it, and that's the vehicle. Because with the services, the vehicle is the mobile has a mobile part, the vehicle as we know it, but it has some servers outside with a lot of information that are important, for example, the maps. And yeah, the communication has to be secured. And I think this is here your company is doing a good job to support this and find out the problems and solve them. And yeah, and this is also a big challenge to do that.
Absolutely. You know, in my opinion, this is like still, well, we have the regulations like UNECE WP29, UNR 155, UNR 156. We have the standard ISO 21444, but still, I think it's the automotive cybersecurity is still at its beginning. What do you think, Stefan? What's your take on that?
Yes, I also think, because as I already mentioned, the automotive industry has done a good job the last 100 years, but the mindset is of mechanical engineering, I say.
Exactly.
Now
I
it's
100% agree.
switching towards software technologies. And if you think of mechanical engineers, it's more or less I have a problem, and the new problem that I have to solve is almost like the old problem that I have already solved, but I have to tune the parameters a little bit, and then I get the solution. But with software, one bit makes a difference. And this thinking is totally different to mechanical engineers than to software developers. So the software developers, they have this in their blood, that they have to think about it. Mechanical engineers have to be trained to this, and therefore I think this is the topic, and therefore we have the big lag at the moment and the challenges in automotive industry to close this door or this gate of problems, because the car is a product. It's amazing product, actually. It started with combustion engines, then the steering, then then it comes software technology inside. Then also the law is changed about these vehicles and so on. And now it's like a technology attractor. Every technology goes through the vehicle or comes in the vehicle, and gets then commodity later on, like sensors or other stuff, or controllers and so on. And I think here now we are at the place where the vehicle attracts all the knowledge which is important to do secure developments. And yeah, we see that everywhere in the world, and it's a big topic. And I think there will come mega impulses to the development of vehicles from this part of this science. Yes.
100%. 100%. I have another last question, although I said this would be the last question since you brought this topic. So car hacking or automotive cybersecurity needs a long way to go. We both know it, but we have a good start. We have some regulations, we have some standard. Now, I want you to tell the audience, in your opinion, with all these advances and challenges, what do you think is going to be the most positive impact of all these technologies in the society?
So I think that I think the Arabic fairy tales, they have kind of autonomous platform. It's the flying carpet. I think it's in our heads to have for everything some miracles or some machines autonomously doing what we want to do. And I think we will solve this problem with autonomously driving, or just telling my vehicle, I'm here and I want to go there, and take the route with the lots of interesting sightseeing points. So
I love that. So Stefan literally said that Aladdin's magic carpet is going to be reality. I think that's the perfect topic to end today's conversation. Stefan, thank you so much for the stimulating discussion. It was amazing having you here.
So Hassan, thank you very much for this very nice and lovely interview. It was my pleasure to be with you, and I keep the fingers crossed for your company, for you, and for our autonomous developments.
Thank you, Stefan. Thank you so much, everyone, for listening or watching this podcast. If you have questions, comments, feel free to write in the comment section. We'd love to answer your questions, and Stefan would be more than happy to answer your questions. We're going to put the link to our to the master's program, and if you want to know anything else, please feel free to write comments. Thank you so much. See you in the next episode.